All right, let's jump right into this explainer. We are going to bridge that massive gap between effortlessly generating AI code and actually deploying a secure, production-ready app. We hear so much about how fast you can build things now, right? But we just don't hear nearly enough about the hidden landmines waiting for you when you push that vibe-coded app out into the wild. Honestly, shipping unvalidated AI code is a lot like building a skyscraper on a fault line while blindfolded. It goes up incredibly fast, but the foundation is a total mystery. So, that's exactly what we're going to fix today.
Here's our roadmap. 1. The vibe coding revolution. 2. The security debt trap. 3. Net ready and stopping AI hallucinations. 4. Securing APIs with proxies. 5. Mastering cloud run deployments. And 6. Going from prototype to production.
Section 1. The vibe coding revolution, shifting from syntax to intention.
We're seeing this massive shift away from writing rigid syntax and moving toward orchestrating ideas. This is what lets small teams or even solo devs validate concepts at absolutely breakneck speeds. As Andre Karpathy pointed out in early 2025, the bottleneck in software development just isn't the coding anymore. Code is abundant, code is cheap. The real bottleneck now is context and intention. Your mental model fundamentally has to change. You're no longer a typist hammering out functions line by line. You are stepping into a managerial role, orchestrating an AI agent to build the architecture for you.
Think about the tools we're using right now. Google AI Studio is basically your zero setup sandbox. As Six Eyes Academy highlights, it's the perfect place to test a prompt because it lives right in your browser. But when you're ready to graduate to real software, you've got to bring in terminal-native agents like Claude Code. Claude Code isn't just spitting out snippets. It actually reads your entire repository, understands your complex project structure, and executes native Git commits. The pros are actually using both fluidly. They rely on AI Studio for rapid ideation and then tag in Claude Code for the heavy lifting right inside the terminal. Section 2. The security debt trap. The hidden cost of fast AI prototypes. Now, what's slightly terrifying about all this new speed is what we are quietly leaving behind in our wake. A highly vulnerable prototype can so easily slip into becoming a business-critical application, amplifying enterprise risk before anyone even realizes what happened. A recent IBM report actually coined a term for this: security debt. See, when you vibe code an application, the AI operates on the path of least resistance. To get your app working in 5 seconds, it might hard-code a database password or leave your backend APIs completely open. If you don't aggressively audit and catch those shortcuts, you are inviting a catastrophic breach. So, to really grasp the danger here, we need to ask ourselves, what happens when you blindly trust an AI to measure reality? Because it's not just about massive security flaws, it's about basic accuracy. Code that simply compiles is a far cry from code that actually tells the truth. Section 3. Net ready, stopping AI hallucinations by building deterministic front ends. Let's look at Net Ready. It's a network diagnostic tool born from a failed earlier version, and its core philosophy is the ultimate antidote to the vibe coding trap. The original developer actually ran an early vibe-coded version of this tool on a machine that was completely disconnected from the internet. The result? The AI happily made up a full, glowing report card giving the offline network an A grade. This happens because generative models are basically the ultimate people pleasers. They want to be helpful, so if they can't find the data, they just hallucinate plausible numbers instead of awkwardly reporting a failure. So to fix this, they had to engineer the people pleaser out of the app entirely. They dropped the generative AI API completely and moved to a highly auditable, data-driven rules engine. NetReady now guarantees that the exact same network evidence will always produce the exact same deterministic answer. They literally stripped out the entire generative AI thinking layer. Now it relies strictly on standard web APIs to check connections and runs that raw data through an offline rules engine built in TypeScript. It is a fantastic reminder that sometimes boring code is significantly safer code. The best way to fix AI hallucinations is to completely remove its physical ability to guess. By forcing the app to be brutally honest, you completely avoid the trap of guessing just to keep the UI looking pretty. In NetReady, if fewer than 3 network checks conclude successfully, it explicitly returns an indeterminate result. It flat out refuses to say your network is fine if it can't mathematically prove it. This highlights why explicit failure states are just vastly superior to graceful degradation when you're dealing with AI-assisted software. This is exactly the kind of rigid validation logic you need to explicitly prompt your AI agent to build. Section 4. Securing APIs with proxies, because hiding keys isn't enough. A beautiful, honest front end means absolutely nothing if your backend is secretly handing out free computing power to the entire internet. You might feel totally secure knowing your API key isn't exposed in the browser, but as we're going to see, hiding the key is only half the battle. Actually, relying on automated deployment tools often lulls developers into a really dangerous false sense of security. Without explicit backend rules restricting which AI models can be queried, a clever user can just hijack your Cloud Run service and run their own expensive tasks on your dime. A developer named Storage Freak demonstrated this perfectly. He built a simple English grammar app in AI Studio, and he used their one-click deploy to Cloud Run. The API key was safely hidden server-side, right? But he just opened his browser's developer tools, pasted a script into the console, and asked his own endpoint to call the much heavier Gemini 2.5 Flash image model. He asked it to draw a nano banana in a fancy restaurant, and to his shock, it worked instantly. His basic grammar tool was hijacked into a free, public image generator, racking up costs on his billing account. To stop this kind of hijacking dead in its tracks, you absolutely have to implement a minimal same-origin proxy pattern. As outlined in the major Reddit vibe coding guides, step 1 is moving the request server-side. But step 2 is the actual secret sauce here. You must implement a strict server allow list. For example, your proxy should only permit routes specifically named geocode or grammar check. If a modified request comes in asking for image generation, it hits that allow list check and boom, it gets blocked with a 403 forbidden error. Hiding the API key on the backend just isn't enough. You have to explicitly restrict what that key is legally allowed to do. Section 5. Mastering Cloud Run Deployments. Escaping the UI deployment traps. The reality is, you just can't rely solely on proprietary UI tools forever. Eventually, migrating to a mature CI/CD pipeline requires getting your hands dirty with the underlying server state. If you've done CI/CD work, you know the shared trauma of the silent failure, where your build gets a giant green checkmark, but the live website doesn't actually change. A developer named Nandan ran into exactly this. He tried moving his AI Studio app to a proper GitHub CI pipeline. The build passed perfectly, but the live Cloud Run site absolutely refused to update. Turns out, Google Cloud Run had a hidden, sticky annotation glued to the service configuration from that very first AI Studio UI deployment. He literally had to export the raw YAML, manually track down the stuck tracking tag, and force a replacement via the command line. Now, if your prototype doesn't inherently need a dynamic backend, kind of like that NetReady app we discussed, GitHub Pages provides a frictionless, zero-cost escape route from all those complex server risks. VibeDojo did a great deep dive on this. Zero-cost static hosting is the ultimate security sandbox for AI frontends. You just have the AI generate an HTML file, commit it, and GitHub host it instantly via their global CDN. More importantly, you get native Git rollbacks. When an AI agent inevitably goes off the rails and breaks your UI during a session, you just revert to the previous commit. Plus, static site hosting completely removes the API proxy hijacking vulnerabilities entirely because there is no backend server to attack. Section 6. From prototype to production. Crossing the finish line safely. Take a hard look at your architecture, because this checklist is your ultimate reality check. If you align with that middle column, you are strictly in a demo phase. Look closely at long jobs. In a demo, your AI might write a standard blocking await call for a database query. But in production, if a task takes over 5 seconds, a block and call will trigger a catastrophic server timeout, and your users will assume the app crashed. You have to prompt the AI to implement job IDs and progress channels instead. And what about webhooks? A demo just logs them. In production, webhooks must be cryptographically signed and idempotent to prevent replay attacks. These are the rigorous engineering standards that fast-paced vibe coding almost always skips right over. Transforming the chaos of AI generation into a structured, predictable workflow takes intense discipline. The absolute biggest mistake developers make is dropping a massive feature request into the chat window and asking for everything all at once. You have to restrict it. Tackle a single concern per session. Do a back-end proxy refactor entirely independently from polishing the front-end UI. Furthermore, write a one-page spec document and pin it to the AI's memory. If you don't explicitly tell it, use only Tailwind for styling, no custom CSS, it's going to drift and invent new styles. Pinning that spec ensures the agent never forgets your architectural constraints as the codebase grows. So I want to leave you with this thought to challenge how you review your AI-generated code from here on out. Is your latest AI prototype truly a product, Or are you just one viral launch away from a massive security breach? The AI might have written the code at light speed, but at the end of the day, you own the risk and the responsibility. It's up to us to ensure our foundations are secure, deterministic, and fully battle-tested before they ever reach a real user. Thanks for joining me for this explainer, and happy but safe coding.